guys, welcome back to this course. In this particular topic, we are going to take a look at how do we create a space frame structure for these kinds of roof structures or these kinds of surfaces. So what we are actually looking at over here is this particular surface. This may be a roof structure or an organically created structure which can have a single curve, a double curve, it can be a doubly curved surface, a singly curved surface, that does not matter. What we actually want to achieve over here is the ability to create a space frame structure on any kind of a surface, and that space frame structure should be parametrically controllable. So that's what we have done over here using this particular script. So as you can see, we input this surface, and as the output we receive the space frame structure that you can see on the screen right now. And this entire thing is parametrically controllable, which means you can control the thickness of these pipes. You can increase them and decrease them. It might take a little bit of time to increase or decrease them, and as you can see, you can increase these thicknesses. I'll just do Ctrl Z and go back to the original thickness, and you can also go ahead and change the surface division, the surface domain, which means you can change the count of the space frame over here. So it's 15 by 10 for now. I can just make it 10 by 10. I can just type 10 over here, and I can decrease the count just like that. And I can also go ahead and change the height and the depth of all of these things, which means if I use this thing right here, if I decrease this particular value a little bit, and as you can see, I'm able to decrease the height of the space frame. I can also increase it back. So let's understand how do we create this kind of a structure and how do we technically manipulate it and create space frame on any kind of a surface that we can find. So let's go ahead and take a look at how do we create this particular script from scratch. So I'll just go to File and click on New Document, and I'll create a new document over here and create this entire thing from scratch. So the first thing that we need over here is we need to create a surface in Rhino so that we can import it inside Grasshopper, or we can reference it inside Grasshopper. So you just need to click on surface from 3 or 4 corner points over here, which is the shortcut, and you need to create a random surface like this. Make sure that the ortho is turned off. Maybe I'll create something like this. I have a random surface. I'll just select it and I'll turn on the control points using this particular shortcut. Select 2 of its control points by holding shift of opposite corners, and I'll use the gumball tool to change it like this. So say we have something like this, and I actually want to create a space truss structure for this particular roof over here. So I'll just select this and turn off the control points using the right mouse click. Now once you're done with this, you can actually import this inside Grasshopper. So you can just double click and type surface and bring in the surface component. You can right click and click on set one surface and click on this one, and there you go, you have the surface imported inside Grasshopper. Now if you want to delete this Rhino file, and if you don't want it to interfere with your Grasshopper file, because what happens is if I delete this Rhino file right now, you see that this gives me an error, which means the Rhino file has to be opened along with this Grasshopper file. If I just do Ctrl Z and go back, and if I don't want that to happen, so after importing something or after referencing something, you can just select that, do a right click, click on internalize data. What that does is it brings the data completely inside Grasshopper, and now you can freely delete off this surface and your data will still be there. So now that we have internalized the data, make sure this is changed to high quality, and now we can continue working with this particular surface over here. So the first thing that we can do is surface division. We can divide this entire thing up by using the divide domain square component that we have been using in several topics now. So you can just double click and type divide domain square. So you have this particular component. You can just click and bring it in. You can find this component right here under math tab inside the domain section. Plug this in over here. You can give it a U and a V count. So let's give it a 15 by 20 U and V count. So you can just double click and type 15, which is a shortcut for number slider. You can also double click and type 20, and there you go. So you can just attach both of these things under U and V count. Now to visualize this, we'll have to use the isotrim component. You can double click and type isotrim have the isotrim component right here, and find the isotrim component over here under the surface tab under utilities. So you can attach your surface to surface and your domain to domain, and there you go. So you can turn this view off so that we can only see this thing right here. So you have 15 by 20 patches of this surface. So we have made 15 by 20 divisions. So after you're done with this, the next step is to convert this entire surface to a mesh so that we can extract the edges. We'll not be going into details about mesh geometry because that is out of the bounds of a beginner level Grasshopper course, but we'll be converting it into a mesh geometry just to extract the edges. So you can just double click and type deconstruct brep. You have the deconstruct brep component, which you can find right here, which is under the surface tab under analysis. So I'll just attach surface to brep, and as you can see, everything is broken down now. I'll turn this off. Everything is broken down into patches and points and lines. So after you are done with this much, now what we can do is we can create a mesh using all the vertices that we have. That is all the points that we have. So you can double click and type point, bring in this point component, attach it to vertices. These are the points that we have. Now you can just turn this off. Now let's take a look at the data structure of these points. You can double click and type panel, bring in the panel component, attach it to point, and now what you can see is you can see that the entire data structure is grafted and there are unnecessary zeros in the front of all these trees. So we need to remove those zeros, and we know what we have to do to remove the extra zeros. You can just right click and click on simplify. This will actually remove the extra zeros. You can type panel and bring in a panel and actually see that all the extra zeros are now gone. And there you go. You have no extra zeros. So now after you're done with this much, you can actually construct a mesh from all these vertices. You can double click and type construct mesh. The construct mesh component, you can click and bring it in. You can actually find this component right here. It's there under the mesh tab under primitive. You can find it over here. Construct mesh constructs a mesh from vertices, faces, and optional colors. So we are constructing the mesh from all the vertices over here. You'll plug it in and you can actually see you have a mesh geometry. I guess I have brought in two mesh objects. I'll just delete this. So as you can see, it has constructed a mesh geometry. If you cannot see any lines of the mesh geometry, I'll suggest you go inside display and click on preview mesh edges. Now you can actually see all the mesh geometry lines, all the inner and the outer lines. After you're done with this much, let's extract these lines. So you can just double click and type mesh edges. So you have the mesh edges component over here. So you can just double click and get this in over here like this. You can actually see where this belongs. Mesh edges component is actually there under the mesh tab under analysis right here. So what this does is it will give you the naked edges. It will give you the internal edges of this particular mesh geometry. So you can just turn off these unnecessary points, and now you need to extract all of these edges so we can move on with our space frame structure. You can attach mesh to mesh, and now you see you have all the edges. So I'll just turn off this mesh preview and I'll now continue with this. So what we need to do over here is we need to actually merge all of this data into one single group. So you can just double click and type merge, bring in the merge component. This component you can actually find over here under the sets tab under trees. You can find merge right where the arrow is shown. So now you can actually attach naked edges to data 1, interior edges to data 2, and non-manifold edges to data 3. You don't have to worry about data 3, it will just pop up on its own. If you need extra inputs, you can just click on these plus signs and increase the inputs, or you can click on the minus signs and decrease the inputs. So I'll attach this to D3 and I'll just decrease and only keep it till D3. After you are done, as you can see, all this data is actually grafted. You can just right click and flatten it so that all these lines are in one single list. So after you are done with that much, now the next step is to actually convert all of these things into a curve so that you have all the upper network ready, which means now this is the upper network that we have. We want this to be in a single component. So you can just double click and type line. You can bring in the line component, which contains a collection of line segments. You can use this to hold all of the lines. You can actually find this line component right here under parameters and under geometry. We could have also used the curve component, but let's use something different in this case. So you have the upper network over here, so I'll just disable the preview of everything else. Now let's go ahead and see how to create the middle and the lower networks for the space frame. Now the next thing that you can actually do is you can use evaluate surface component out of the isotrim component that we have used. So we have this surface right here. We can use the evaluate surface component for this. So you can just double click and type evaluate surface and bring in the evaluate surface component. Now you need to understand why we are doing this. We want to extract the centers of each one of these boxes so that we are able to move them perpendicularly below all of these boxes. Now in order to get a perpendicular direction, we need the evaluate surface, because you see you have the normal output. So if you input the surface and give it a point, it will give you the normal output, and this is what we actually require. So as we know, we always have to reparameterize the surface, otherwise it will create errors. So just right click and click on reparameterize. Input this surface, and inside point you need to input a UV coordinate. So MD slider gives us U and V coordinates at the same time. So just double click and type MD and bring in an MD slider component. You can increase its size a little bit, attach it to point, and there you go. You have the centers of each of these surfaces. If you think the panels are way too big or way too small, you can go under display, click on preview plane size and decrease the plane size. I'll just change it to 2, press enter. I guess 2 is also a little bit too big. I'll change it to 1, and now I guess you can see clearly that we have all the planes. They are arranged in a perfect order, because we actually have the normals of all of these centroids that we just extracted. You have all the points, you have all the frames. So after you have that, you can just go ahead and also extract the average of all of the vertices that you have over here. So I'll just double click and type average and bring in the average component and extract the averages of all the vertices that I have right here. So doing this will actually give you all the vertices that you require. So after you're done with this, you can actually move all these geometries. You could have also used the area command for the faces. So if you don't want to use this, you can just double click and type area, bring in the area component, attach it to faces. This will also give you all the centroids. So maybe I'll use the area command. I think it's much better than that. So you have the area component, you have all the points, you have all the frames from over here. Now what you can do is you can actually move these points in a perpendicular direction right below using this particular normals. So let's do that. You can just double click and type move, bring in the move component. Now let's understand what we are moving. We are moving these points, so attach them to geometry, and as you attach them to geometry, you see they automatically move in the z-axis, because in the motion you already have one translation vector which is 0, 0, 10, and 10 is in the z-axis position. That's why it moves by 10 units in the z-axis, but we actually need it to go in the minus z-axis. So let's create an amplitude for that. So you can just double click and type amplitude. An amplitude is attached to the vector, so you have the normal from over here. Now we need to be able to control the the normals that come out of here. That's why we are using the amplitude component. Normal goes inside vector. These are the vector normals. These are these particular directions, the perpendicular directions. Now we can actually give it an amplitude. So let's give it an amplitude with a negative component. You can just double click and type maybe 1.000. Maybe that can be your maximum height, and you can just type negative and bring in a negative component so that it goes down. So this will go inside amplitude, and now you can attach it to your motion. And as you attach it to your motion, you see that something like this happens. But we actually want only one single point to move, not all these groups of points. So in order to fix this, what you have to do is you have to understand first that the geometry is grafted. These values are grafted, but the vector values are not grafted. Because if you just double click and type in panel and bring in a panel component, so as we have seen in the data tree topic, that when you are actually grafting something, both of the things have to be grafted together, otherwise they don't go in sync. So you see this, all the points that I have are grafted. You can see the data structure, they have separate lists. but all the vectors, they are not grafted, they have only one single list, the one list. So what you can do in this case is you can graft this input. So you can just right click and click on graft, and there you go. Now every point has moved in the perpendicular direction using what you have right now. So I'll just go ahead and turn this off so that it's clearly visible. Now you can see every point has moved in the z direction, in the minus z direction, which you can control using this.